Example number 12. Calculate the pH of the solution after adding 10 milliliters of 0.05 molar KOH to 40 milliliters of 0.025 molar benzoic acid. The Ka for benzoic acid is 6.3 times 10 to the minus 5. So the first thing we have to do is find out what the volume to the equivalence point is, and then decide is that 10 milliliters before, at, or after the equivalence point. Okay, so let's walk through the solution. So let's first determine the equivalence point. We have monoprotic acid, monohydroxy base, so we can say that MAVA equals MBVB to find the volume of the base added at the equivalence point, 20 milliliters. Okay, so 10 milliliters is before the equivalence point and is therefore in zone 2 after a small amount of acid has been added. Okay, base has been added. Okay, zone 2 is when some titrant is added from the burette before the equivalence point is reached. So let's walk through the neutralization first. So we have benzoic acid. Now 0.001 moles comes from the concentration of the acid, 0.025 times the volume, 0.040. Okay, so 0.025 times 0.040 is 0.001. The number of moles of KOH is the same. It's just the concentration, 0.05 molar, times the volume added, 10 milliliters, so 0.01 liters is 5 times 10 to the minus 4 moles. We are before the equivalence point, so we're going to neutralize all that base, and we end up with 5 times 10 to the minus 4 moles of our acid. Okay. We can find the concentration by dividing by the total volume. 40 plus 10 is 50 milliliters, or 0.05 liters. So we have 0.01 molar acid. Now, in the neutralization, we generate our conjugate base, C6H5OO minus, the conjugate base of that benzoic acid. We create 5 times 10 to the minus 4 moles just by the stoichiometry in the neutralization. And again, if I divide that by 0.05 liters, I get 0.01 molar conjugate base. Okay. Then, because I have a buffer situation here, I use the Henderson-Hasselbalch equation to solve for the pH. The pH is the pKa, or the minus log of the Ka, given in the problem as 6.3 times 10 to the minus 5, plus the log of the base concentration over the acid concentration. And we get a pH of 4.20.